Hello, today in mathematics we'll be looking at the topic lowest common multiples of prime numbers. LCM of whole numbers, prime numbers and prime factors. LCM is the smallest multiple of numbers that each one can make when you multiply it. The smallest multiple of numbers that each one can make when you multiply it. While prime numbers are natural numbers that are divisible by only one and the number itself. Prime numbers are numbers that are divisible by one alone and the number itself. In other words, prime numbers are positive integers greater than 1 with exactly two factors. The two factors are 1 and the number itself. 1 and the number itself. Some of the prime numbers include 2, 3, 5, 7, 11, 13, etc. If you look at these numbers I just mentioned, they are divisible by themselves and 1 alone. That is what makes them prime numbers. And let's solve some questions under this topic. Find the prime factors of 144. To find the prime factors of 144, we can use the method of successive division by prime numbers. Here is how it works. We're going to start with the smallest prime number, which is 2. After 1, 2. So we start dividing by 2. We divide by 2. Since 144 is even, we start dividing by 2. 144 divided by 2 is equal to 72. Since 72 is still even, we divide again by 2. So 72 divided by 2 is equal to 36. 36 is also even. So we are going to divide by 2 again. 36 divided by 2 is equal to 18. We are going to divide by 2 again because 18 is even. So 18 divided by 2 is equal to 9. 9 is no longer even. So 2 cannot divide 9. If 2 divide 9, there will be fractions. So we go with the next prime factor, the next smallest prime number after 2, which is 3. So we're dividing, that's why we're dividing by 3. So we move to the next prime number, which is 3. 9 divided by 3 is equal to 3. We divide again by 3. Since 3 is divisible by 3, so 3 divided by 3 is equal to 1. So we are going to pick our prime factors. We have reached 1 and the division process is complete. The prime factors of 144 are 2 raised to power 4. 2 raised to, we start by dividing by 2 first. So we divided by 2. The first time we divided by 2, that's 2 raised to power 1. Divided by 2 again, 2 raised to power 2. Divided by 2 again, 2 raised to power 3. Divided by 2 again, 2 raised to power 4. That's how we got 2 raised to power 4. Then when we divided, we now went switched to dividing by 3. When we divided by 3 the first time, that's 3 raised to power 1. Divided by 3 again, 3 raised to power 2. So that's how we got 3 raised to power 2 here. So our prime factors are 2 raised to power 4 times 3 raised to power 2. These are prime factors, that's the number. So the prime factors of 144 are 2 and 3, with 2 appearing 4 times and 3 appearing twice. That's 2 raised to power 4 and 3 raised to power 2. 2 appeared 4 times and 3 appeared twice. Let's take another example. Find the prime factors of 60. To find the prime factors of 60, you can follow these steps. Start with the smallest prime number, which is 2. So we're going to start dividing by the smallest prime number, which is 2. 60 is divisible by 2. So we're going to divide by 2. We're going to divide 60 by 2. 60 divided by 2 is equal to 30. We're going to continue dividing by 2 since 30 is divisible by 2. So 30 divided by 2 is equal to 15. 15 is no longer even. 2 can no longer divide 15. When 2 divides 15, we're going to have fractions. So I'm moving to the next smallest prime number, which is 3. So 15 divided by 3 will give us 5. 3 cannot divide 5 without fractions. So we'll go to the next smallest prime number, which is 5. So when we divide 5 by 5, we get 1, and we've come to the end of the division. So our answer, the prime factors of 60 are 2. We divided first by 2, that's 2 raised to power 1. Divided again by 2, that's 2 raised to power 2. So we have 2, that's 2 raised to power 2, and 3, then 5. So our prime factors are 2, 2, 3, and 5. And in the exponential form, it is written as 2 raised to power 2, 2 exponent 2 times 3 times 5. That's our prime factors, the prime factors of 60. Let's take another example. Find the prime factors of 390. To find the prime factors of 390, you can follow these steps. Divide by the smallest prime number. So let's start with the smallest prime number, which is 2. Since 390 is even, it is divisible by 2. So divide 390 by 2. When we divide 390 by 2, we get 195. 2 can no longer divide 195 because 195 is not even. So we'll check the next smallest prime number. We'll check the next smallest prime number, that is 3. 3. The next prime number is 3. And the sum of the digits of 195 is 1 plus 9 plus 5. The sum of the digits of 195, 195. 1 plus 9 plus 5, which is equal to 15. And 15 is divisible by 3. So we're going to divide 195 by 3. When we divide 195 by 3, we get 65. We continue with the next prime number. Since 3 can no longer divide 65 without us getting fractions. If 3 divides 65, we're going to have fractions. So we'll go to the next prime number, which is 5. And 5 can divide 65 without that, and the answer will be a whole number. So we divide 65 by 5. 65 divided by 5 will give us 13. The last quotient, finally, 13 is a prime number. Since 13 is a prime number, it cannot be divided further. 13 can only be divided by 1, and it's so. So we've come to the end of the division. Thus, the prime factors of 390 are 2, 3, 5, and 13. The prime number, they are 2, 3, 5, and 13. That's our answer. The prime factorization of 390 is 2 times 3 times 5 times 13, which will give us 390. This has brought us to the end of this exercise today on prime LCM of prime numbers and factorization of prime numbers. Assessments. Find the prime factors of 84 and 136. Drop your answer at the comment section. That will be all for today. See you in our next demo. Thank you for watching.